Welcome back. I'm Dr. Angela Siegel, and today we'll cover more about methods. A quick review of what we can expect within the form of a method, and that is as follows. We see that we have the static keyword, and this implies that this particular method is not invoked on an object. Then we have the return type of the method, in this case an integer. The name of the method, in this case sum of numbers, and then the list of parameter variables and their type. So we see in this case we have 4 parameter variables, all of type integer. And finally, recall that there is a return from the method to the calling location. So if this is called from main, this sum would be returned to the main method. When creating a method, it's very important to create appropriate comments and place these above the method. To write an appropriate java.comment, which you'll find many IDEs will help you create, you want to proceed as follows. So use a /*, a description of the method, the purpose of what the method is there for, and then describe each parameter variable. You'll see in our example that we have a method given the name triangle area, expects 2 argument values. They'll be received into the parameter variable base and the parameter variable height, both of type double, and this will calculate the area of a triangle based on that base and height and return it in the form of a floating point number of type double. So you'll see the java.comments for this begin /*, so there's that one extra asterisk that explains that this is a java.comment. And the first thing that we include is the purpose of the method. So in this case, it computes the area of a triangle. Then we describe each parameter variable in order. And so first we have the length of the triangle base, then the length of the triangle height. And after you've completed description of each parameter variable, you finally include @return. And this describes the return value that the user of this method can expect. When we call a method, we typically will pass some argument values along. And these are received by parameter variables in the called method. Both of these must be of the same type. So the argument value that is passed must be of the same type that is expected by the parameter variable that is receiving it. The argument value that is passed can be either the contents of a variable or a literal value, such as a number or a string. The parameter variable is declared in the called method, as we saw on the previous page. It is initialized with the value of the argument value that it receives. The parameter variable is used as a local variable inside the called method. Here are some steps in this parameter passing. In our example here, we look back again at our triangle area calculation, which is expecting 2 double arguments, receiving them into the parameter variables base and height. So if we look at the main method, we see that it creates a double variable named triangle1. And then it's going to assign it the value that's returned from a method call to triangle area. We are going to call the method triangle area, and we're going to pass it 2 argument values, 4.2 and 8.0. And we see that as we do that, they're going to be received in the parameter variables base and height. Base and height then, at that point, are declared and initialized as the values that were passed. So base becomes 4.2, height 8.0. Then we step into our method, our triangle area method, and we see that we create a new variable area, and we initialize it with the product of 0.5 times the value of the base and height. So 0.5 times 4.2 times 8.0, or 16.8. This variable is then returned. And what that means is we send whatever is held in the variable area back to the location at which this method was called. And so this is returned, and this is the value, 16.8, that is assigned to our variable triangle 1. And that completes the parameter passing. So there are some common errors that we have to be mindful of. First of all, let's take a look at our main method. In it, we can see that we create a double variable named price, and it's initialized to 10.0. Then we pass that variable price to our method calculate tax. And so price and 15.0 as passed as argument values, and they are received into the parameter variables total and tax rate. So price is sent and received into the parameter variable total. So when that is passed to the method calculate tax, we see that we create two variables, total and tax rate, and they are initialized to 10.0 and 15.0, as expected. We then proceed with the method, and we see that we set a new variable, tax, of type double, and we initialize it with a calculation, total times tax rate divided by 100, which is the same as saying we're going to initialize it with the value that is 15% of 10.0. 10 times 15 over 100, or 1.5. So this is the tax that we would expect on the price that was passed to us. If we were paying 15% tax rate, we would spend $1.50 for every $10 item that we purchase. Now, we see on the next line that we set total equal to total plus tax. So what we expect that's doing is changing total to total plus tax, 10 plus 1.5, or 11.50. First of all, this is dangerous. Generally, we don't want to change our parameter variables. We want to leave them as they are when we receive them. That's the way forward. However, this is also not good practice, because since we passed a variable in, we might expect that we've updated the price, but in fact, we haven't done anything. This has no effect outside of this method. So despite the fact that price was sent and held within our parameter variable total, it doesn't affect the price at all. So the total is locked in at 11.5, but the price remains unchanged. Next, we'll take a look at return statements. We declare a return type in the method declaration. You can see in blue that we have the return type for this example as double. This particular method is called triplet, and it expects one argument of type double. As we look inside the method, we see that it takes the incoming argument and multiplies it by 3. This is then returned in a return statement. A return statement returns a value. This is what sends a value back to the location from which this method was called. You'll see at the bottom we have the return statement, and it is pretty straightforward. It's the keyword return followed by some value. This return statement immediately terminates the method and returns to the position from which this method was called. It passes the return value back to that calling method. The return value may be a value, a variable, or a calculation, and the type, importantly, must match the return type. So you can see in this example, the return type is of type double. The return value must also be of type double. Thankfully, it is. A method can use multiple return statements. It's important to note that every branch must have a return statement. In this example, we see that we have a method named checkTemp, which is checking the temperature of a thermometer, for example. And it expects one argument of type double, and it will be held in a parameter variable named temp. This method will return a string, as we see described in blue. Within the method, we can see that there are 3 separate return statements, and they do cover every possible branch. If the temp is less than 36.1, it's going to return invalid reading. That's not a valid temperature to take with a thermometer. Else, if, so otherwise, for those values greater than or equal to 36.1, we check again if the temp is less than or equal to 37.2. If it is, we return normal temperature. So we will return normal temperature in all situations where the temp is between 36.1 and 37.2 inclusive. For all other cases, we fall into this else category, and there we return fever indicated. A quick look at this in flowchart form is the following. If the temp is less than 36.1, we will return invalid reading. If it's not, we check again, is the temp less than or equal to 37.2? If so, return normal temperature. If not, return fever indicated. A common error is a missing return statement. In this example, we've taken our previous method and we've reduced it a bit. If the temp is less than 36.1, we still return invalid reading. But this time, if that is not the case, we do a second check. We check if the temp is greater than 37.2 and return fever indicated. But what if the temp is set to 37.0 or 36.5? If we receive any argument between 36.1 and 37.2, there's no return. And what that looks like in flowchart form is that one of the branches is missing. So we come in, check if the temp is less than 36.1, and do what we've always done, return invalid reading. If we end up on the false branch, so if the temp is greater than or equal to 36.1, we do our second check, which is we check if temp is greater than 37.2. If it is, we return fever indicated. If it's not, we don't give any further direction. This is an example of a missing branch. So that being said, return values are optional, which is not to say that they're optional when they're expected. In the previous example, we declared the method as returning a string, and then we failed to do so under certain circumstances. We can, however, choose to not return anything. Here's an example, public static void underlined text that takes in a string argument. So this void in blue tells us that nothing will be returned. Nothing is planned to be returned. In this case, what we're doing is we're taking in a string, we're finding the length of the string, outputting that original string, and then outputting an appropriate number of dashes such that we underline the string that we just read in. It's a pretty simple method, but the point is made. There's nothing that needs to be returned. We're just doing something. And there are times where it's really useful to just do something with a method. So there are methods that take in information, make decisions, and return some information, but then there are those that just get things done. And this is an example of something that's just getting it done. While no return statement is required, a return statement without a value is allowed. And that just lets you know that you are returning, breaking from the method. And there are times that this is really useful. So while this method would work even when the length of the string is 0, here's an example of an optional return value that would just save us a few steps. So in this case, we check if the length of the string is 0 and return. If you use a return statement without a value, it will return and the method will terminate immediately. None of the following statements will be executed. In this example, there are two separate return statements. It's kind of like the break that we've seen before. There are times when you're reading through code or writing code that you realize that there is repetitive code. In this example, we see two blocks of code that basically both do the same thing. The first asks a user to enter a number between 1 and 12. The second, a number between 1 and 31, so capturing a month and a day. And we want them to be valid values for a month and a valid value for a day. And so we want to put bounds on what a user is allowed to enter. While the range of values that we're allowing are not the same, the logic holds. We want it to be within a range, and we want to keep asking the user for more information until we get a value that is expected. As such, this is when we can consider a parameterized method. So we can take that information and use parameters to help us take a method and let it apply to more than one situation. So in this case, you can see from the Java.doc comments, we're prompting the user to enter a value in a given range until valid input is provided. In this case, we have two parameters, low and high, and we'll use them to mark the low end and the high end of the range. Then return the value provided by the user once a valid value is received. Instead of initializing to -1, because we're allowing this range to go from low to high, we'll set that initial value to low -1, making sure that we're lower than low. And then proceed by checking until we find a value that is between low and high inclusive. Now that we've been creating all of these methods, we might think, this is dangerous. What if I create something in the main method and something in another method and they both have the same name? This is not something we have to worry about, and that is thanks to something called variable scope. The scope of a variable is the part of the program in which it is visible. Variables can have different levels of scope, from local to block to global scope. Variables that are declared inside of a method, including the main method, are called local variables. They are only available inside the method in which they are declared. Parameter variables are also local variables. Variables declared inside of a block of code, so anything starting and ending with curly braces, have block scope. The scope ends at the end of the block. Variables declared outside of a method have global scope, and they can be used and changed by code in any method. We'll see those later when we explore objects. Here are some examples of scope. In this main method, we see that we start by declaring an integer variable sum of squares and initializing it with a value 0. Next, we have a for loop block, where we have an integer variable I that is allowed to run from 1 to 10. And then inside of it, we declare an integer variable square. Sum of squares is a local variable in the main method. And what that means is the scope of this local variable exists from where it was declared to the end of the method in which it is declared. So from int sum of squares all the way to the end of the main method. I is only visible in the for loop block. It's declared right at the beginning, and it is available until that for loop block ends. The same is true for the variable square. Square is visible in the for loop block, but it doesn't come into existence until it is declared a little bit further down. Local variables are called local for a reason. They are available within the method that they are in, but they are not visible to other methods. In the following example, we see that the local variable side within the main method is not available to the method find volume. Side is a local variable in main, and so it is only exists from the point that it is declared to the end of the main method. When it is referred to in find volume, this causes an error. It wasn't passed, it's not a parameter variable name, and so it's not accessible. We've described methods as a black box, and often we will split up work within a team of developers and have various team members work on different aspects and different methods that we require. We're not required to understand the naming conventions that they are using because the reuse of variable names is not a problem. Variables declared inside one method are not visible to other methods. They are two different variables and do not overlap. So in this example, it's okay that in main we have a variable named result. The result is a local variable in main. And it exists from where it's declared to the end of the main method. We can see that in the method find volume, there is another variable named result, and it is a local variable within find volume. Its scope exists from where it is declared in find volume to the end of the find volume method. These scopes do not overlap. What about for block variables? Variables declared inside one block are not visible to other blocks. They are two different variables and do not overlap. So in this example, we see that we use the integer variable I as a block variable for the first for loop, and we use another integer variable I in the second for loop block. Both are block variables, both exist only to the end of the for loop block, and then they're no longer available. So these scopes do not overlap, and we're free to do so. In fact, many programmers use I, J, and K for their loop variables without any issue. The takeaway: variables must have unique names within their scope. You can't declare a second variable with the same name that is within scope. However, if you're familiar with variable scope, you might find that you can reuse names quite a bit within your code.
What is the object of all this? How does it all fit together? What comes next?
Interesting that you ask. Next time, we will explore objects and we'll learn how all of this fits together.
Thanks for watching.
See you next time.